Okay, let me explain it once again. Transistor, it is we connect two PN junction back to back to form an NPN structure or a PNP structure. Okay, so with this kind of structure, we call it as a transistor. Okay, so we connect two diodes in reverse way to say it is a transistor. No, we can't do that. Okay, this is a basic diagram of the transistor. How come we have some? Just a minute. How come I have some stones on my shoe? Okay, I found the stone. Okay, so you have to remember the diagram. So we have two types of components. We may not go through very deep. Okay, one is the transistor. So if you can remember it, it's good. But if you can't, you can just skip it. It is not that important in the exam. Okay, but if they ask you about it, you can try to memorize. If you have, especially if you are very good at electronic components. Okay, so we got an NPN. So you see that if the N is in the middle, the arrow is pointing inward. Okay, pointing the inward. If it is P, then the arrow is pointing outward. So simply as that. Okay. So you just they may just give you a diagram and ask you, hey, what type of transistor is this? Or they may ask you, they will let you compare between the transistor and FET. Okay. So if you can remember this diagram, it's good. It's a plus. If you can't, you can study more on other concepts instead of hard facts. Okay. B is called base, which is the middle of the transistor. C is E is emission. Okay, E is emission. And C I forgot. You can check it on your own. Okay, so we got different applications for a transistor. So the first one is we use it as a switch. Okay, the transistor, they got 3 legs. Okay, so if okay, like this way, right? So it is an NPN. So we can control the B here and adjust the voltage of B, the base. So we can use it as an on-off switch. Okay, you can see. So still remember that we got different threshold for different kind of semiconductor, right? For germanium, it is 0.3 volt, and for silicon, what is the voltage? Do you still remember the threshold?
0.7?
Yeah, 0.7, exactly. So if I can apply a high voltage, a slightly higher voltage than 0.7, so I can use it as a switch, so the current can pass through. But if not, say if it's a silicon, okay, if it's silicon, if I don't apply voltage in it, it is closed, right? But if I adjust and turn on the voltage of it, it can be used as a switch to control the circuit. Okay. Do you understand? Yeah, I guess so. No, I see Cynthia is a bit confused.
Okay.
Do you still remember how the semiconductor works? Not really. I will draw a diagram. Oh, collector. Thanks a lot. Yeah, the C is collector. Let me draw the diagram once again. Okay, how to? Or should I just connect my iPad? Maybe I can try connect my iPad to the screen. Because this type is this part is quite important. They will ask you questions. Of course, they will ask you questions on semiconductors. So if you can't remember what is the semiconductor or some very basic very basic information on it, you will be in trouble. So I will pay more attention. I'll explain more on it. Okay. Hey, just a minute. Let me. great. Not draw? What is the word? I forgot what is the app I can use to draw stuffs. Freeform. Yeah. Can I draw it now? Draw it now? Nope. How come? Never mind. I will just use the okay. Just a minute. Let me turn on my pen. Okay, great. So can you see that?
Yep.
Oh yeah. Just a minute. Let me go through a full screen first. Yes, but I don't know why they didn't show all the stuffs here. Okay. Yeah. So basically you got stuffs like this is NPN, right? Or in a normal dial, it is NP. So what does N stands for? N stands for negative. And P stands for positive, okay? So for negative, why is called negative? It's because it is full of electron, okay? And for this side, they may have some ions in it, and we call this kind of, what it is called? This is called electron receiver. It will receive electron, okay? So what is the net flow of the electron? It will goes in this direction, right? If I give them a battery. So if the electron move, they will give you what? They will give you a current. Okay? This is how the electron can work, okay? So similarly, you can do the same stuffs in a transistor. This is how the NP works. Electron move, so they have current. And let's go back here. Transistor, they do the same, okay? So if you give them a voltage here, you can just think it as a conductor, okay? So you can use it as a switch. And the second application is amplifier, but I don't think they will ask you how to use a transistor for amplification. You just need to know it can be used as a switch or amplifier instead of the exact diagram, exact component, okay? So why I have to mention amplifier to you is because we will use a lot of amplifiers in our radio. The signal we received may not be so strong that we can hear. We cannot hear directly the signal is. So we need an amplifier to have a louder signal or larger signal to decode, okay? So you see that it is different. They use different pins for the connection, okay? So you see the input here, they connect the input from the base, okay? From the base, and the output will become, what is this? What is this like? This is a C, right? This is a C. Let me check my collector. Yeah, collector. Collector. Thanks, Alvin. Collector. So the output will at the collectors. Okay. This is how the amplifier works. But a very that is fun thing to remind you. The signal itself is the resource, and the amplifier itself also needs a voltage source. If you don't provide a voltage source, if you don't provide electricity here, the amplifier cannot works. Okay. So you see that's why they have two voltage signs, right? One is the signal itself, another is the battery to power the amplifier. Okay. Okay. So amplifiers we use. Let me explain one more. Okay. For the switch, the transistor can be used as a switch, right? But nowadays they use MOSFET, because MOSFET has a lower power consumption. Yeah, that's why they use FETs instead. We will talk about FETs later time. This is not that important in our syllabus. Okay, amplifiers. So we use amplifiers to amplify the circuit, amplify the signal. Is it like that? So in the past we used vacuum tubes, and now we use transistor, or sometimes we may use integrated circuits. So in my slides, I will explain to you what is class A, B, C. Class A, class AB, class B, class C. These four types of amplifier to you. But in reality, they got more types of amplifiers. For example, they got amplifier called type class D, and D stands for digital. But we will not go through that, okay? So in your mind, you know that we may not just amplify analog signal. We can also convert it to digital signal and amplify it. This is how class D works. But I'm not going to do too deep in it, okay? Okay. Blah 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 blah. Very clumsy, huh? But bear in mind that it is just to amplify signal, and we are not going to too deep in the definition, but we'll talk about all four kinds of amplifiers we have, and all four kinds of amplifiers have different how can I explain it? Features, yeah. Yes. So I have to explain it to you. For class A amplifiers, normally it is used in audio. Okay, it's used in audio. But still, in some cases in radio, we will also use it. Hey, so what is the feature? What is the most important part of it? Class A amplifier, it can do the amplification lossless. Lossless is the character of it. Okay, lossless. It won't create any loss. Okay, so what is the input of it? It will just amplify it the signal. So you see that the wave sign is not clipped or chopped into pieces, right? The sine wave is still the sine wave, but in different amplitude. Just the amplitude change. Okay, the amplitude become larger. This is the class A amplifier. So you see that the power current flows of is 360 degree. What it means that it powers at all time. Okay. So however, and it works very hard. The efficiency is low. So there's some saying that you don't have you can't just work very hard. You also have to work smart, right? So sometimes you can. Oh, this is just a diagram for you to reference. You don't need to memorize this one, okay? You just have to memorize the right hand side. Just the right hand side. The right hand side is enough. Class A amplifier will amplify all the sine waves, all cycles. They work at all time, very hardworking, but they are not skillful. Okay, so their efficiency is very low. You need a lot of power to do the to do the amplification. So it is not that common to use in handheld radio, because handheld radio you need a battery, right? You don't have a lot of power, so you won't use all the amplifiers, use all the amplifiers in a class A amplifier. Okay, we just use one or two, especially in the intermediate frequency. So what is intermediate frequency? We will go to the next two lessons. I will explain it. I'm prepared to bring the notes of it now. For class B amplifier, okay, normally it would use both of them in a second. Okay, so it works only half the cycle. It only works half a cycle. Like you are working 12 hours a day, so you are not working at all time. So it saves a lot of energy, right? You only have half of the time to do your work. So you see the efficiency goes to 65%. It saves a lot of energy. But it will only help you to amplify half of your signal. So that's why in our, if we just use Class B amplifiers, we may combine both of them. One to amplify the positive signal and one to amplify the negative signal, okay? But you remember that Class B only do half of the job. Not that efficient, but better than Class A, worse than Class C, okay? This is the characteristics of Class B. They only do half of the work. Okay, and so we have talked about A, we have talked about B, right? So what's coming next? Is Class AB, not C. Get. Why? So you see that Class AB is actually very, very smart. Okay, so for this one is just a combination of two voltage. So you see this output signal may not be very good. But this one, okay, let me explain it to you. If we just use a Class A amplifier, we just have half of the signal, right? So actually it is adding up two signals. It is a flat curve and a flat curve. So actually it is not that smart to use. But for Class AB, it will choose from time to time. If the signal is less than 0, they will switch to another amplifier. So that's why for Class AB amplifiers, we must use both of them at the same time. We must. Okay. So you see that it is slightly larger than 180 degree, and it is better than using Class B amplifier alone. Okay. So in the previous class, PK sir mentioned that Class AB amplifier is two Class B amplifiers joined together. But I have checked the information. I think there is a very slight difference in it. But of course, you can think in this way. Class AB is two Class B joined together. But in reality, they got you see there are some circuits behind. So they will choose, if the signal is too low, they will jump to another amplifier. But this diagram will not. Okay, this is the smart why we say Class AB is smarter than Class B alone. Okay, they have some circuits here to help you to choose at which moment which amplifier should I use. Okay, they will see the phase difference. Okay. So you see that it's more than 180 degrees. They will have a zone here. So you see that Class AB, they will have a zone. This is the crossover zone. Okay, so at some time point, they will have two amplifiers working at the same time. Okay. So Class AB is very good, but they also they will need some more technology for the manufacturers to do the handover very well. Okay, if the handover is not doing it very well, the signal, you will hear some weird signals. Okay. Yeah. Okay, the last one is Class C amplifier. So the Class C amplifier is the smartest. They don't even do it half a cycle. 24 hours a day, they may be just doing 8 hours. Okay, they are not doing half of the day. But you see that the efficiency is very, very great. Okay, so it is high efficiency, but not doing doing a lot of work. But it is commonly used in the antenna amplifier. Commonly used in the antennas amplifier. Because in the antennas amplifier, we use very high frequency to try to emulate some kind of digital signal. Okay, not that digital, but we will have demodulation. Okay, so I will explain what is demodulation in the next lesson. So I think it is have some encoding and decoding system. Okay, so for very high frequency, if they don't, even though they may not do a lot of work, they can still amplify the signal and decode it very well. Okay, this is the property of the high frequency EM wave, radio wave, high frequency radio wave. So that's why it is very commonly used in the amplifier of antenna. Very efficiency, save a lot of energy, and for the antennas, we don't need to do lossless amplification. Okay, we don't have to do lossless amplification. That's why we use types class C. Yes. So in the diagram, you see the last part of the amplifier which connected to the antenna. You must know that this amplifier must be class C amplifier. Do I need to draw a diagram? Okay, really okay. So I don't draw the diagram now. Okay. So this is just a physical explanation in physics saying why we can use class C amplifier in high frequency wavelength, which is the antenna. So if you have time, you can take a look. But if you can't remember the physics very well, just bear in mind that high frequency wavelength, type C, high frequency signal, class C amplifier. This is a match. Okay. Summary. Okay. So you see that class A, they work in full cycle, worst efficiency, like 20 to 25% efficiency. Class AB, they do slightly higher than half a cycle. Class B work exactly the half a cycle. So for class AB, they will have has some time points, two amplifiers working at the same time. Okay, they have some little overlap time. Class B, no, just 100 degree. Class C, they do less of the work. So you see the conduction angle, they may be just doing 1/4 of the cycle, or 1/3 of a cycle, but must be less than 1/2 of the cycle. Okay. But type D to T, we're not going to explain it. Okay, but type D is digital. They can do very good. Maybe. Okay. Oscillator. So what is oscillator? For oscillator, in most of our circuits, we will need a frequency generator. Okay, we need a frequency generator. So, or sometimes we have a signal generator. Okay, signal generator. In computers, maybe it is because of time, or some chips must work at different frequency. Okay, like the serial port, they have to do at the 90 megahertz. So that's why you have to make sure the chips is working at exact frequency. You need an oscillator to help you to synchronize the clock. Okay. So the oscillator consists of amplifier from positive feedback loop to output to input. Okay, they will control the signal. So we will have different form of oscillator. Inductors with capacitors, the LR circuits, or we use crystal circuits, quartets, crystal. Okay, stacking quartets. Quartets have a very good characteristics. They are not easily affected by temperature. Okay, so they can do a very stable job. They are not easily affected by others. That's why you see that it is very common to see quarters in the circuit. Okay, do you still remember the LC circuit? No. Anyone still remember that? No one remember. Okay. You have to memorize some of the characteristics of LC circuits. Oh, so before the LC circuits go to resonance, they will oscillate. The current and voltage. So you see the magnetic field. They will have a time for fluctuation for the voltage and current. So we will see that it is a kind of oscillation. Okay, before it reaches resonance. Okay, so should you remember what is resonance? Right? Not. Okay, just a minute. Let me do the job. Just a minute. So what is resonance? So actually, I have one lesson extra in my lesson plan. So I guess I can do some more revision, especially to the math. Let me see if I can. If I can. Oh yeah. Alvin is correct. Yes. The root LC. Ah, thank you very much. You you pay attention in my class. Okay, let me do a screen mirror first. See if I can show you. Oh yeah, great. So you see here, right? Okay. Oh, it's not working. Let me do the job. Just a minute. Hey, how come my okay, let me put my reboot my iPad. Most of the time when you go to HARTS, it doesn't work. I don't know why. It is very weird, but it happens from time to time. Okay, let me just reboot it. Okay, so for an LC circuit, do you still remember that we have two electronic components? One is called inductor, and one is called capacitor, right? So capacitor and inductors, they have different. The formula for the reactance is XC and XL, right? So if Alvin and Angie's remember what is the formula, I should just write it on the board so that it makes my job easier. I see Alvin's remember the exact formula, so I'll do it on the board. Okay. Let me grab a piece of paper first so that I can erase the board. Thank you. Maybe I need to make one extra lesson for the revision case. So for inductor, it is a coil, right? The XL equals to 2 pi FL, right? For capacitor, XC equals to 1 over 2 pi FC, right? So at resonance, XL equals to XC. But before they reach the resonance, you will see that the voltage may go stamping like this, okay, before they reach resonance. So that's why we call it as oscillate. Okay. So XL and XC, when they are the same, you will see that the proof is 2 pi FL equals to 2 pi FC, right? So 2 pi F square LC equals to 1. F equals to 1 over root 2 pi. I'm sorry. 1 over 2 pi root FC. This is how they do the resonance, okay? The formula. So if they are connected, if they have a circuit in this way, so you see, of course, they will do the resonance. And the voltage, the impedance will become like this at resonance. This is in parallel. In serial, the voltage, the impedance will become, this, okay. It is likely to ask you questions, so you have to memorize the LC of resonance. Because there is a very important feature at resonance. We will use these features to tune our radio circuits. That's why you have to know what is the LC resonance, okay? If you don't use the LC circuits, you even can't tune your radio. That's why you need to know. Okay. Okay. I can't use my. Just a minute. Just a minute. Just a minute. Can I? Can I? Oh, okay. So before it can works, okay, it works. Very great. Very good iPad. Okay. Once again, let me explain to you. LC circuit. Just a minute. Just a minute. Just a minute. Hey, hey, hey. Come on. Okay. Never mind. I'll just skip this part. Hope you can memorize this one. Okay. This is inductor. This is capacitor. If you have a circuit connected to this way, this is in series. In serial. This is in parallel. Right? You still remember this? This is in our last lesson, okay? Or last two lessons. Okay, so before they reach the resonance, there's some fluctuation in voltage and current. So that's why this is called oscillation. So the formula, it is Xc equals to XL, okay? When it is at resonance. So 1 pi Fc equals to 2 pi FL. So F equals to, this is how they do the job, okay? At resonance. But before they do resonance, one side is stronger, one side is weaker, so that this will eventually goes to a how can I say it? A balance point, okay? I remember that I included it in my notes, and I used LaTeX to type it. I remember that because it is very hard to do the last test job. It takes a lot of time. Okay, okay. So I've just explained. We can use LC circuits to do the oscillator. Okay. This is just for your reference to let you know LC circuits can be used as a oscillator. You don't have to memorize this diagram. No, don't memorize this diagram. Cause I have more complex stuff for you to memorize. No, I'm joking. I'm just joking. Yeah, I just want you to let you know, the inductor itself can store energy, and it can goes with LC together to use it as an oscillator. Okay. So if you're interested, you can see that. Oh, this is an example of it. Okay. Crystal oscillator. It is more important, and I want to spend more time on it. Okay. So you see, this is 16. It is 16 megahertz actually. Okay. Crystal oscillator. You can use a crystal oscillator to stabilize, and it's very accurate. So you just use a sharp razor to cut the quarters. Okay. So the thicker the you can control the thickness of the quarters to change its oscillating frequency. This is how the industry level they do the work. Yeah. So that's why you can see for this kind of crystal oscillator, they got different numbers here. It is about changing the thickness of the corset. Okay. So you see there is a very long paragraph here, right? But the only terms you have to bear in mind is crystal oscillator or quartz oscillator is accurate and stable. It won't change a lot. It won't being affected a lot by temperature, okay, or other environment factors compared to the LC circuit. But there are some points we must use LC circuit. I'll explain when we will do it, okay. And it provides a single frequency of oscillation. So if you use a quartz oscillator, your frequency must be fixed. You can't try to adjust it. But LC circuit, you can use variable capacitor to change the oscillating frequency. Yeah. It is an equivalent circuit. So for quartz crystal, a quartz oscillator, it can be rewrite as this one, okay? So we have talked about a lot of LC circuits, right? And actually, the quartz itself can be rewrite as an LRC circuit. Yeah. So that's why it also have because it has the properties of oscillation, it can be rewrite as an LRC circuit, not in reverse way. Okay. They won't choose the equivalent circuits, but it helps you better and have a better understanding why it can oscillate. Okay. Advantage: the quality factor of crystal is very high. The frequency is really accurate compared to LC circuit, and it can have a very high stability. Okay, but they are very fragile. It is a piece of stone, right? A very thin piece of stone, and it can not withstand a lot of power, so it can be used as a low power circuit. You won't see quartz oscillator in very huge or powerful circuits. But circuits which needs a lot, which takes a lot of energy, you won't see that. Okay. And frequency cannot be changed apparently, right? You cannot open the crystal and use a sandpaper to adjust it, right? Yeah. Okay, so I have to explain two more kinds of oscillator to you. I'm not sure if it will ask in the questions, but these two terms includes in your syllabus, so I have to explain it, okay? But I didn't see it in my exam. So HARTS oscillator, it uses a tap inductor feedback loop, okay? And corporate oscillator, it is just a capacitor, okay? LC with capacitor, okay? So you see HARTS oscillator, you see there are two inductor here, okay? Two inductor with variable cap. And corporate oscillator, it is two variable capacitor and inductor. Okay, it got different advantage and disadvantage, but I'm not going too deep in it. Just remember that HARTS oscillator also use LC circuit, but they use inductors more. Okay, and corporate oscillator, they use capacitor more. Okay, this is the main difference. Okay, so these two circuits, as you see there is a variable capacitor here, right? So you can adjust its oscillating frequency. This is what quartz crystal cannot do. Okay, it have some rooms for change. Okay, but I remember that HARTS oscillator, because it's used inductor, inductor more, they can withstand a higher frequency. But corporate oscillator, they can do more fine-tuned stuff. They can do more precise stuff. But these two circuits can be replaced, used to replace quartz. If your circuits cannot withstand a lot of energy, you need a circuit to withstand a lot of energy, and you need to change your frequency from time to time. Okay. A simplified circuit. So you see that I just circled the red part to you, right? So you see that the main part, the main working component is here. Two capacitor with inductor, HARTS, two inductor with a capacitor. In Chinese, yeah, no. Oh, can't see. Oh, I can't see the board because can't see the board.我頭先寫咗咯，我頭先寫咗喺度，我專登揾 iPad 啊，你好彩，我記得。OK， Yes, that's all. And so we will take a break now. So we have finished the remaining materials of last lesson. So we have talked about the alternating current, what is that about, how to calculate, and for standing wave, I see Michael mentioned about SWR, the standing wave ratio. Standing wave ratio, we will talk about it in the next 2 lessons when we talk about really radio transmission. So we will go through the hands-on part, try to let you have a taste of what calling radio is and explaining every component to you, and we will go back and explain it one by one to you. Okay, and we have do the transformer stuffs, what is the matching device, how to do the coupling, and solid state drive. We haven't do the frequency changes, frequency multipliers, and demodulators. We'll go through it in upcoming lessons. Okay, I'm preparing the notes of it, the mixer kind of stuff. Okay, but we'll have upstream what is oscillator, why we have to use crystals, amplifiers, audio rate, why we have to divide it into we have to use type A amplifier and type C amplifier from a different scenario. Type A, lossless, used in audio. Type C, very efficient, used in signal transmission, high frequency. Okay, and also explain what is NPN and how to what is the working principle, power rectification. I've explained to you, right? The rectifier. Okay. So I have some time left. No, I'm joking. So I will leave this part in the next lesson. We'll go to the hands-on, and I have plenty of time to prepare my notes in next week. Okay. Okay. So I will bring my computer with me so that you can try to see the hands-on part. Okay? But I'm not going to do the recording in the hands-on part. So let me stop my recording first.